up. And you can imagine that would be a hard case. You'd have to be like, go ventilate, 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 it's diffusing in. So there's always going to be a little bit of anesthetic gas in the alveoli on emergence, right? And try to wash it away. They do have an extractor. They have these activated charcoal filters that you can put on the expiratory and the inspiratory limb of your circuit, and activated charcoal, so as the patient expires their anesthetic gas, it attaches to that activated charcoal, and it's a scavenging unit for expired anesthetic gases and even inspired. So we don't use those for waking the patient up, but we do use those for if we have an anesthesia machine and the patient has malignant hyperthermia, and we absolutely do not want them to even have one molecule exposure. Put these charcoal filters on the inspired and expiratory limb on a machine that previously might have some anesthetic gases hiding somewhere in the nooks and crannies, and it'll absorb it, and we can have no exposure to ventilation agents. Activated charcoal. Question.
It's like to wash out like salmon, where it gets, essentially you would set your fresh gas flow without any vapors to the same as your ventilation.
Oh, for wake up?
For wake up.
Higher.
Higher.
Dilute, 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 dilute.
Okay.
I throw it up to, what I do is I'll throw it up to 10 to 15 liters and make sure you have a machine that doesn't go and increase then your volume, but most of them are volume controlled now, so you don't have to worry, and pressure controlled. Just flush, 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 high liters. I'd go 10, 15 liters, flush out, exceed minute ventilation, exceed. But you're right, so I could go and ask you a question, which is brilliant. At which point will wash out I don't know how I would ask that.
Which setting for long?
At which point does rebreathing cease? At which of the following carrier gas flows prevents rebreathing of a patient with a 5-liter minute ventilation? A carrier gas flow of 1, 2, 4, or 8? 8, because it exceeds minute ventilation. Now there's no rebreathing. Or what if I said 1, 4, 5, or 8? 5, 8. 2 answers are correct. 5, because at 5, there's no rebreathing. We hit their minute ventilation. At 5, there's no rebreathing. And anything above 5, there's no rebreathing. Okay, chemistry time. If we're going to work with molecules, we better be experts and understand them. With this, anybody here a chemistry major? Right, they sold you out. They sold you out. For those of you who are chemistry majors, minors. For those of you who are chemistry minors, chemistry majors, we are not going to be purists. We are not going to be purists. We are going to look at traditional nomenclature, and we're going to look at IUPAC, the International Union Nomenclature rules. But we are not going to be purists in that we have to have ethyl before methyl because E comes before M. It has to be in alphabetical order. I don't care. As long as you call a methyl group a methyl and an ethyl called an ethyl, I don't care if you call it ethyl methyl or methyl ethyl. I don't care. I want you to be able to look at a gas molecule, the structured stick figure molecule, and be able to identify that gas. I want you to be able to go and look at the IUPAC or the traditional name and be able to identify what that gas is. If I tell you 1,1,1 tetrafluoral diethyl methyl whatever, I want you to be able to tell me what that gas is, and I want you to be able to draw it. That's what we need to learn from this. So, I say rules. It's kind of like being how you all speak or when you come up to where me and Dr. McDonough live in Yulee. It's all about being able to communicate and getting ideas and getting an understanding. So with you all being wonderful like you are, and you live in Yulee, as long as y'all know what I'm talking about, we're communicating. Or you can speak proper IUPAC nomenclature and be absolutely grammatically correct. As long as you get the communication across and go from one to the other, you can answer those test questions. You could certainly be able to apply it and look sharp in the OR, and you'll pass boards. That's where we're at. So, if you don't know your functional groups, learn them. Memorize them, know them. It's everything we do. We are clinical pharmacists. You don't know your functional groups, go home and study them and memorize them. So let's look at our inhaled anesthetic agents. Inhaled anesthetic agents. Diethyl ether, that came out a few short years after Dr. McDonough was a nurse anesthetist and delivering anesthesia. 1844, we had nitrous oxide. All these ones that like to blow up, and they said, wow, maybe it's not a good idea to have explosive anesthetics. 56, we had halothane. It's a really nice anesthetic, not so good. It gets metabolized in the liver and has toxic byproducts. Since kids have immature livers, they can take halothane. If y'all do mission trips, you may use halothane in other countries for pediatrics. Not so good for adults because it can cause what's called halothane hepatitis, bad for the liver. Then we had Ethrane in 1974. Ethrane or Enflurane, good anesthetic, kind of created a little EEG activity that appeared to be seizure-like activity. Followed quickly thereafter by Isoflurane, still available today. An all-around good, generic, cheap, inexpensive anesthetic that tends to linger because it has relatively high solubilities in all of our tissues. Desflurane in 1992. Desflurane, very quick, low solubilities, very good for quick wake-ups, is irritating to the lungs. But do not equate Desflurane airway irritation with increases in airway resistance or bronchoconstriction in any way. This and this and this and this and this are bronchodilators. But if you were to go into the OR and take a sniff of this, you're going to cough. If you take a sniff of this, you're going to say, sweet, with slight floral overtones. Very good year. I love it. So, and what I want you to do, see these red, muy importante. Red, 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 red. Obviously, I want you to especially know those. I want you to understand these in this order. Halothane, Ethrane, Isoflurane, Desflurane, Sevoflurane. You will always think of all of them in that order. But why, Mark? Because that's when they were born. They are all essentially siblings, in order. But if you memorize them in that order, H-E-I-D-S, hides or heeds, just know it in that order. All going to make sense when you see. This one is unique. This one, switch an atom, is this. Switch an atom is this. Switch an atom is this. Know them in that, and bing, a bang, a boom. They all make sense on how they were synthesized. All makes sense. So, halothane is unlike the other one. It's an alkane. It's just a straight hydrocarbon that's been fluorinated. Also known as fluethane. 2-bromo, 2-chloro, 1,1,1-trifluoroethane. If I were to give you that, I want you to be able to draw that in a stick figure. And that's pretty simple and straightforward, and I think you can do that. Then our halogenated hydrocarbons. Hydrocarbons are nothing more than hydrogen to a carbon chain. Gasoline. Do you ever pump your own gas? Of course you all do, because you weren't even born when we used to go in and they'd be like, fill her up. Okay, fill her up, sir. And they do that and they come over and they clean your windshield, check your oil. Those days are gone. So now you all pump your own gas. Did you ever get high doing it? Come on, nobody sniffed the fumes. Right, right, you did. All right, well, the next time, if you were to sniff gasoline, it will make you lightheaded and dizzy. It will anesthetize you. It will do a lot of other bad things too, but it will anesthetize you. It is a hydrocarbon. That's what hydrocarbons do. Hydrocarbons like to dissolve in fats. And let's face it, we are all fatheads. Can't help it, we're all fatheads, because that's what our brain is made out of. Lipids. Lipids are fats, we are all fatheads. So if somebody comes and says, you're a fathead, well, thank you. I'm very smart, thank you. So Ethrane, followed by Isoflurane, followed by Desflurane, Sevoflurane. Here are their names. I don't have to read them for you because you can memorize them. And then there are our non-volatile anesthetic. These are all inhalation agents. These are our volatile agents. And this one all by itself here, the lonely and organic gas, which should be banned, is nitrous oxide. Terrible, terrible, terrible. This is the Dr. McDonough gas. But it is great and it's very forgiving. Give it, they go to sleep fast, turn it off, it disappears real fast. This is super, super fast. So if you want to look good, you want to look smooth, wake your patients up, use nitrous oxide at the end. You'll look golden. Chemical structure of our inhalations. I don't care about methoxyflurane. You're not going to use it, you're not going to see it, so ignore it. So let's start with halothane, the alkane, the single hydrocarbon that is not an ether, the one that does not have oxygen in it. The others have oxygen in it. This one does not. Now, I'm going to tell you a mnemonic so that you can remember. It's not my mnemonic. If anybody is offended, it's Dr. McDonough's mnemonic. Now remember, all the fluorides are together. So it doesn't matter if you put the chloride here or chloride here. I don't care. I don't even care if you put the hydrogen here or hydrogen there. Chatty Cathy had fun with Clarence, Bruce, and Harry. It works. It works. All right? So what we have is we have a carbon chain that has been fluorinated, or I would say halogenated. The halogenated agents we found is we put on halogens, which are very reactive species. We don't want these things alone. They're really bad. They're toxic. They're irritating. They want to steal electrons or give somebody electrons. That's what they do. Very reactive. So we have Chatty Cathy having fun with Clarence, Bruce, and Harry. That's our halothane. Then they went and said, you know, these sniffing gasoline is not bad. Halogenated gasoline puts you to sleep. All right, but you know, it has things like, I don't know, toxic byproducts. It's got a fair amount of metabolism, and it hurts our liver. So let's come up with something better. And they were realizing that ether, that stuff that Dr. McDonough used to put a mask on with a little gauze, and then he'd take the bottle of ether, and he'd pour it on top, and they'd sniff it. And that's why he is like he is, too. And it has scavenging units. You ever wonder? That's don't tell him I told you that. That's what it is. He's a brilliant man. He's nuts. He's dropping ether for all those years. Well, they realized that this is your ether. Carbon, oxygen, carbon. So if we start tweaking that molecule, we start getting some really good benefits. So one of the early ones that they came up with was this fluorinated ether that had a chloride ion on it, on the end. Now, it's called Enflurane, like on the end, fluoride. Well, that's actually not right. It should be second to the end fluorane. Or chloroflurane or something like that, but they didn't name it right. But on the end, which isn't really the end, there's a chloride. All right? So it should be N-chloride fluorine. So remember it as that, N-chloride fluorine. On the end, there's a chloride. So we have N-chloride fluorine. So this was a good anesthetic, but again, it has some drawbacks. One of the big ones would appear to be EEG, seizure-like activity. So they said, you know what? Let's tweak that molecule because we know isomers, I don't know, kind of have different properties. So let's see what an isomer, isoflurane, isomer fluorine. So we have Enflurane, we have N-chloride fluorine, isomer fluorine, and then they're like, so we had this all through the 80s. Very good. But again, the solubilities with these were relatively high. So they put you to sleep a little bit slow to wake up. They'd linger. You know, it was very, very good anesthetics. They were stable. So they were nice anesthetics. So then they said, hey, never to rest on our laurels. Let's tweak these anesthetics and come up with some better anesthetics. So they went and said, you know what? We're realizing if we halogenate these things, they become better. And fluoride is a really good halogen because when we put fluoride on these molecules, they get better. Let's get rid of that chloride. Let's add another fluorine. Get rid of the chloride. Put another fluorine. So now, how many fluoride ions do we have? 1, 2, 3, 4, 5, 6. So we have Desflurane. So now they go and say, let's put more fluoride on Desflurane. Then they say, we're running out of room. Well, let's add another methyl group and load that up with fluoride. They're hydrocarbons, particular ethers, so let's add a carbon and load that up. And now we have sevoflurane. Did I say 7? Sevoflurane, 7-fluorine? I did. So we have N-chloride fluorine. We have isoflurane. We have Des-5-fluoride, and we have 7-fluorine sevoflurane. Easy. Now you can just write these things off in your sleep. Chloride's on the end. Isomer, move the chloride. Get rid of the chloride, make it 6 fluoride ions, and then 7 fluoride ions. Simple and easy progression. From when you first looked at it, it was like, oh, that's so hard. So let's look at IUPAC nomenclature. IUPAC, name for organic compounds, contains these 2 parts. A root, indicating how many carbon atoms are in the longest continuous chain of carbon atoms, and a prefix or a suffix to indicate the family or functional group to which the compound belongs. These are our root names. Just know them. Meth, eth, prop, but, hex, hep, oc, non, deca. Okay? Just memorize them. Which you probably already do know them, right? Yeah, I know, it's not but, it's bu. All right, functional groups. Know them. I don't have to read them to you. Know them. So let's look at our volatile anesthetics. They are halogenated hydrocarbons. 2 main categories are alkanes, which are carbon chains. What's the difference between an alkane, alkene, and an alkyne?
Double bond.
Very good. You guys are good. And then our ethers, carbon, oxygen, carbon. There's our basic 2 main. Which volatile anesthetic falls into this one? Okay. And which ones fall into this one? Nitrous oxide falls into this one or this one? You guys are good. Okay. Halogens. Again, we found that if we add halogens, they are very reactive, but they increase our potency, they increase the beneficial anesthetic aspects of our agents. These are strong reducers. They tend to give electrons to others. These tend to be strong oxidizers. They like to take. This is the group we're talking about. And we don't have to memorize the periodic table or any of that neat stuff. But These are the things that make our anesthetics what they are. Question? Xenon. We don't use it. Xenon and argon are noble gases, and they are very good anesthetics. The problem is noble gases are rare. And we don't have a way, it would be nice, we could put an anesthetic gas into the patient, very little of it gets metabolized, even less gets transpired, it all gets expired. So what we put in, if we could catch it and rebottle it, boy, we could use this over and over and over and over again. The problem is, argon is going to be real expensive. We don't have a way to put it into the body, collect it, keep it concentrated, and use it for the next patient. So we're not even going to talk about argon. We're not even going to talk about neon, any of those. Alkanes are single-chained hydrocarbons. Alkenes are double bonded. Alkynes are triple bonded. Ethane, 2. Single bond, ane. See how easy this stuff is? Nomenclature. The smallest alkane to exhibit isomerism is butane with 2 isomers. 1, 2, 3, 4. 1, 2, 3, 4. Isomer A has 4 carbons in a chain, so it is butane. Ane. Single chain. Isomer B has 3 carbons in a chain, and the 4th carbon branching off the center. To name such compounds as this with IUPAC system, choose a root name to indicate the longest chain. Longest chain takes the name. The longest chain takes the name. So that would be, what's the longest chain? And what's on the other branch? A methyl group or a propane. Methyl propane. So easy. My 3rd grade daughter does this. Count the longest chain. If the carbon chain is 1, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane. Real easy. And we don't have any anesthetics that are getting up to here. Makes sense? So, number the carbon chain starting with the end closest to the substituent, the branch. And always try to get the lowest possible number for numbering those substituents. So we look at this. We would not want to start numbering this way because this substituent group is closest, so it's 1, 2, 3, 4, 5, 6. So what would the base name, root name be? Hexane. Okay. And then, what's this group?
Methyl.
And this group?
Methyl.
So we have 2 methyls. And what numbers are they on?
2, 4.
2 and 4. Okay. What if I was to say 2 methyl, 4 methyl, hexane? Could I get you there? I could get you there. Wouldn't be the right way, but I'm from Yulee. So, have you all looked at these and named these already? Write them down. 1, 2, 3, 4. And we'll name them. Who wants to start? Sure, thank you. First one's easy. Yeah, you.
2,4-dimethylhexane.
What do you agree?
Yes.
Good. Second one.
2-methylhexane.
Okay. Third one.
Still working on it.
Okay.
I got hexane and then 2,3-dimethylhexane.
2,3-dimethylhexane. Good. And the last one.
2,3,4-trimethylhexane.
Trimethylhexane. Okay. So easy this is. With that, right?
That's not a methyl.
The second one's a
Ah, this is not a methyl. What is that?
Oh, yeah,
That's all.
Ethyl.
Yeah,
Thank
I
you.
didn't
Good
know
catch. Very good. So let's redo this. What is it?
So it's 3-ethyl-4-dimethylhexane.
Did everybody hear that?
So it's
Say it again, please.
3-ethyl-4-dimethylhexane.
Wow, and you even did it in alphabetical order. Did you see that? Ethyl first, then the methyl groups. For Yulia, I would have said methyl, then ethyl, but it's all about communicating. Can we get from A to B and B to A? So good, very good. So, halogenated alkanes, halothane. Let's name this one. What I'm going to do. Go ahead, I want you all to name that one. Who wants to name? Who wants to name it? Sorry.
One. So it's an ethane.
It's an ethane.
And so you have, I'm going to say the first carbon will have the bromine and the chlorine.
Okay.
So one bromo, one bromo, one chloro, 2,2-difluoro, no, trifluoro ethane.
2-trifluoroethane.
2,2-trifluoroethane.
2,2,2-trifluoromethane. That'll get us there.
Ethane.
Ethane. Very good. Let's see what I got here. 2 bromo, 2 chloro, 1,1,1-trifluoroethane. Great. Okay. Alkane versus ether. Herein is the difference. The C2H5 group is known as an ethyl group. However, the C2H5O group is known as the ethoxy group. Below is a table with the most common ones that you'll find. Just add oxy for the ether groups. Just carbon, oxygen, carbon. So, we have two types of ethers, acyclic and cyclic. Straight line ethers, circular ethers. We don't care about the circular ethers, we don't use them. So we're just going to look at straight line ethers. It's easier and easier. Okay, so ethers, the base formula, R, oxygen, R. The RO group is the alkoxy group, and this is the alkane group. Obviously, it's a carbon chain with a single bond. It's the alkane group, and the alkoxy means it is with oxygen. Okay? So we have methoxy, ethoxy, propoxy, butoxy, pentoxy. Same nomenclature as before. So let's see COC. Methoxy, methane, 1, single bond. Here we have methoxy, ethane, 2. Methoxy, 1, 2, 3, propane. And I don't care how you name them, forward, backwards, upside down, as long as we go and we appropriately name that we can go from one to the other. This is also known as dimethyl ether. This is also known as ethyl methyl ether. Ethyl, methyl, there's your ether. IUPAC versus traditional names. If it's an ether, it's a traditional name. methoxypropane or methylpropyl ether, alphabetical or by size, smaller to longer. Usually longest chain takes the name. We're not going to be purists. So if you were to name this methoxyethane, or you went here ethyl methyl, or you went methyl ethyl or ethyl methyl, I don't care, as long as you are technically correct. Okay? All right. Naming substituents in ethers. The longest parent chain is the ethane group. Thus, methoxy becomes the substituent. Hence, the name of this molecule is methoxyethane, or methoxyethane, or ethyl methyl ether, or methyl ethyl ether. Do they not all get you from A to B and B to A? I am not the purist. I go from A to B and B to A, and that's all that matters. So all of these would be correct in Mark's book. So, nomenclature for halogenated inhalation ethers. Methyl 1-carbon, ethyl 2-carbon ethers, which is our substituent substituent group. Here's our ethyl group. There's our methyl group. This is the ether. Enflurane. So, longest chain takes the name, and we name from the substituent. So we have 2-chloro, 1,1,2, trifluoro, difluoro, methyl ether. Or we can go and say 1,1-difluoro, methoxy, 1,1,2-trifluoro, 2-chloro, ethane. One is IUP and one is traditional. Which one's traditional?
Ether.
Yeah. The only thing to do with these is to practice, play games with one another, name them, state them, practice, do them. It'll become very easy. Yeah. Let's look at isoflurane. 1-chloro, we're naming closest substituent group, then name. 1-chloro, 2,2,2, trifluoro, 3 Fs, methyl or ethyl, difluoro, methyl, 1C, ether. Let's have some fun. Does this work? 1-chloro, 2,2,2, trifluoro, ethoxy, 1,1-difluoro, methyl.
Sure.
Could you get to this with that crazy way of doing it? I think it worked. Heck.
I have a question. Can we put the second carbon number 2 as 1 instead? Why do we have to put 1 there?
Why do we have to put here?
Yeah.
Because that's, you start the numbering closest to the substituent group. So that is one of the rules. They want you to start here, closest here. Again, I'm not being a hard stickler. Let's renumber them. But actually, no, it doesn't work then with the real names. No, because then that's one rule we're going to have to follow. That's one rule we're going to have to follow. Because if I were to give you this, and I give you this and a couple other names, you're going to have to come up with this. Yeah, so we're going to have to name closest substituent group. Going to have to. That's one rule we're going to have to follow. Or then we're going to get crazy numbers. Now we're just, now we're going all the way up into. Not talking funny and Yuli. It's going all the way to George. Desflurane. Let's look at this. So we've got 1, 2, 2, 2 tetrafluoros to ethyl difluoro, 1, 2, methyl ether. Or 1, 1 difluoro methoxy, 1,2,2,2 tetrafluoroethane. It works. It works. Oh. Now this one's fun. Yeah, no, there's no straight chain anymore. Which one are we going to call the straight chain? We can't go. No. So, all right. So, we've got two in a straight chain, and one of these is going to be a substituent group. All right. So, it's kind of like an isopropyl, isn't it? Yeah. Let's throw isopropyl in one of the answers if we can. What the heck? All right. Fluoromethyl. 1,2,2,2 trifluoro. Fluoromethyl. The heck's our fluoromethyl? Here's our fluoromethyl. Then we've got, well, we start our number here, 1, 2. This is our chain. This is our substituent group. Then here's our chain. So then we've got 2,2,2 trifluoro 1. This is off of this carbon. Trifluoro on a methyl group, ethyl ether.
Why is the trifluoromethyl in parentheses? Why do you have to do that?
I don't know. Take it off. We're not being hard fast on rules here. No particular rule. I don't
Are
know.
you grading our pen?
All right, your test? No. Nobody's purist on these. Fluoromethyl. 1,1,1,3,3,3. Heck, are we numbering this one? We can't do that.
I think they're saying C is right.
Well, let's take a look here. So we're going to name it as an isopropyl ether 1,1,1,3,3,3 isopropyl. Can we name an isopropyl that way? 1, 2, 3. I don't know. Yes, we can. I suppose we can. Well, it's an isopropyl, so basically we have a carbon here. Can we name a carbon going this way on an isopropyl? Yes, you can, because we're saying it's an isopropyl. So we're saying it's bonded here and it's branched. So we go 1, 2, 3. So we can. But I have to say it's an isopropyl ether. I don't want to confuse you. A lot of different ways to break these names. Or we could be purists. Trust me, you don't want to be purists. Or fluoromethoxy 1,1,1,1. It would actually be numbered this way. 1,1,1 trifluoro 2,2,2 trifluoroethane. That's a tough one making that argument. What do y'all think? 2,2,2. I like this one. IUPAC. 1,fluoromethoxy. We've got that. 1,1,1 trifluoromethyl-ethane. Okay, we can do that. We can do that. We're calling it an ethane, so we're saying it's a straight chain. We've already taken care of the ether group here, all right, when we said fluoromethoxy. That took care of this. So we're calling this a straight chain. That'll work, because we've said it was an ether by counting for the oxygen here. That's taken out. And now we're looking at the 1 and the 3 carbon on an ethane straight chain. Gets us where we're going. Question?
So, for the first one, the fluoromethyl, you don't have to say, like, you don't have to name where that first fluoride is. I mean, I guess there's only one, so you don't have to.
No, you don't. You don't.
And then, why did you put this? So I get through 2,2,2 trifluoro 1. Why does that have to be in parentheses?
It doesn't have to.
Oh, it doesn't have to.
That's my knowledge. Take the parentheses out.
But the last one you were saying it was an ethane, so you're saying it's a chain of 3.
Chain of 3.
Which would be...
We are not being purists here. We are naming the...
Propane, right? A chain of 3?
That's breaking it up into methyl and
Trifluoropropane.
So that's basically calling it an ethane with a methyl group on it. 'Cause without-
Okay, yeah. 1,1-trifluoromethyl. So we are calling it an ethane with a methyl group. We are calling it a substituent group. Okay. Good.
Good. Would it be, in that instance, would it be 1,1,1
Well.
if you're, I don't know, that's where I don't.
Well, which one's closest to the oxygen?
That's the methyl.
Which one's closer to the oxygen?
The beginning of the.
We're numbering 1 here, 1, 2. To which one you asking?
I think it's the,
Yeah, like the 1,1,1 trifluoral, like where's that one? Right?
so it's, okay, that's branching off the first carbon that we're counting as our
Trifluoral methyl.
Yeah, the 1,1-trifluoromethyl is the one all by itself. It's not the ethyl. Okay? See? Trifluoro on the ethane here, the ethyl group. So, there's our official real one. So, this one and this one are the ones that are the kind of difficult ones, right? Right? So you're all looking at it saying, just count the fluoride atoms. Right? Hexa. Just put fluoromethyl. 1, 2, 3, 4, 5, 6, 7. Just count the. What do we got here? Hexafluoro. 1, 2, 3, 4, 5, 6. Where's the other one?
With the fluoral.
Beginning.
fluoromethyl.
Ah, there it is. 7. Good. Okay. 1, 2, 3, 4. 1, 2, 3, 4, 4, 5, 6. This one. Count the methyl groups. Okay? What is this stuff's easy? Oh, cyclic. I don't care about that. Any questions? Any questions? And look at that. What time are we done?
Wow.
7 minutes to spare.
Teaches
7 minutes to
everything you
spare.
know.
Teach you everything you know. That's going to take another 10 minutes.
Can you come like every day?
Every day?
Seriously.
Sure. We'll see about that.
We have our lecture and then you just relate to my input.
And I act it out. They'll give you a lecture and then I'll act it out. All right, today I'm going to be local anesthetic. All right, I'm going to proceed.
What else could you do, like a telepresence
Stop
day for
recording. We're
TC?
done.
Maybe?
Thank you.
You know what I mean, and we can just watch it. We'll come to class and watch it on video. Can you record your lectures at TCU and telepresence them in, and then we can all just come to class and watch
We
it?
do record them. You know what I do for my other lectures at TCU too?
That you should do
Which I
for-
think actually I learned it from Jonathan, Dr. Pablati. That's not it. MP3.
Yeah.
I MP3, and I learned that from him. He still does that? No?
What is it?
Well, you have MediaSite. All right, how do you watch MediaSite when you're in your car?
And half the time we have the.
Oh, he podcasts.
Yeah.
Well, you can play it on your phone and then just.
Oh, cool, okay.
Dr. Nagel Health lectures are publicly available.
I heard, can you send me that link?
Absolutely.
Mark that well over at Gmail.
You should send us yours.
I don't know what boss would allow that. We got a bunch of, y'all been watching, you guys watched Eager's DVD set, didn't you?
Yeah, 1993.
Yeah.
I don't need to see that girl's face one more time.
Anesthesia
I
hasn't
want to see
changed.
what he's writing, not her face.
The physics of anesthesia and how these things behave hasn't changed since 1893 either.
Yes, sir.
That's why McDonough is still, relevant. If I like have fun at his expense, you know why? He's not here.
Because he's terrified.
Yeah, he's a big puppy. He is a big puppy.
You guys live on the same street?